Next software is the monitor software. First thing, it will ask you for some sort of user credentials. So first thing, directly underneath the log on, log off button is your add edit user menu. So if you like, right now I can make a add new user. Jeff, what would you like your username to be? It has to be at least 4 letters. I would normally strongly recommend you make it as short as possible, just because you have to type it in almost constantly. It's easy for me because I get to have the 2-letter one, but so we'll go with Jeff. Jeff, you want to type your password in, or you want to tell me? You probably want something. It's a secret. Okay. So right here, the verified password. There you go. So just type it again. All right, there you go. So we're going to make you a full administrator. So really quick, I'm just going to go through the privileges. So once you select the operator type, you just give it a check mark. And then you can switch between the operator privileges through these little tab buttons on the right. Now, Jeff gets select all and everything. So as far as retort operator privileges, they're all pretty self-explanatory. You have start process, which is you get to start a process, perform operator entries. So in the middle of a cook step, every process you run, it will ask you for certain reference entries. So you check all the reference gauges on the machine and you input that information into the program to tell it everything that's analog on the machine and our reference gauges are all in line with what the machine is digitally seeing. So if you have an operator account, I would suggest all of them have the ability to start processes, all of them have the ability to put their entries in. You don't want anyone, unless they know what they're doing, to override the device. Overriding segments, I'd say it's more up to you whether you want an operator to be able to do that or not. I would argue, yes, you want your operators to be able to do that, to skip steps, to shut the machine down, to start the machine up. PID tuning, that's something almost no one should have access to. That's a very detailed and technical aspect of the machine. And edit analog input bias, which I forgot to mention earlier. So the machine has a digital bias on the temperature it receives, and you can change that in the all view menu, which I can go back and show you in a second. So typically our machines are kept at a bias of -1 degrees. So if -1 degrees at the cook step of the machine. So it should be pretty much in line with what the reference thermometer gauge is reading now. So, but for instance, if when you're running a recipe, you have it at 250 degrees, that's what temperature you have in your cook step for your recipe. The machine will automatically heat to 251. It'll add a bias of 1 temperature. But the machine thermometer is calibrated in such a way that it's 1 degree colder than it thinks it should be. So if you set your recipe to 250 degrees at cook, on the HMI, it will show it controlling to 251 degrees, and on your reference thermometer, it will show the machine at 252 degrees. You can change that bias at any time, and I'll show you how in a minute. But if you want the ability to edit that permission, that's where you do it. Now, directly underneath, under the host menu, you have edit security, which are things like creating users, edit recipe, which is pretty self-explanatory, creating recipes. Then you have scheduling the recipes, which are moving the recipes that you've created onto the retort. View transaction reports, which are, transaction reports are the reports that monitor how everyone's been using the software. So if you need to see, okay, who overrode the machine into shutdown in the middle of a process, you can go to the HMI transaction reports and see, okay, it was this user. Archive data, so when you archive data, it takes it out of the normal database and puts it into a separate database that you can view on your own. It doesn't purge any of the data over time. It tries to maintain all that data. What it does is it just separates it from the rest of the data. So if you had one particular recipe you want isolated on its own for future reference, you can archive that recipe in all its reports. And what that does is it just moves it into a separate archive. You can edit the host options, so that's things like the host computer's timeout window on the login. So if you log in and walk away, you can say, okay, after 5 minutes, it'll log you out. After 2 hours, it'll log you out. Things like that. View process reports. That's viewing the batch reports generated from your processes. That's a pretty typical thing you'd want everyone to have. System configure and electronically sign. Electronically sign is at the bottom of the reports. If you have the administrative privileges, you can click on a button and the button will electronically write your signature down in the reports. That just gives you the option to do that. System configure kind of falls in with the edit securities above. That gives you the option to change the little securities menu, and I'll show you that right now. So yes, we want to save Jeff. And after every change you make, it will ask you why you've made that change. That logs in the transactions menu. You just say, hey, I added a user.
And I wonder, could we, like, for instance, Emma, add her as a restricted user, just so you can kind of tell us what you would recommend?
Yes, absolutely.
Privileges for the average person would be.
So real quick, so we can go add a new user, click add new. So username, now your full name. So user ID, that depends on how you want to, as an institution, handle it. Most of the time I'd recommend you can just make it the full name again. If you have something like a employee ID or student ID you would prefer them used, you can put that there instead. All right. So for a generic retort operator, I would say start processes, perform entries, override segments, and I'd say that's it. And if they're going to be, so are you going to be making recipes or just running the machine?
She might be making recipes. Yeah.
Okay, so we can go to host user, we can say edit recipes, schedule recipes too, so add them to the machine or just making recipes?
Add them to the machine too, sure.
Okay. And we'll say view process reports, and a lot of these are a bit arbitrary, so I'd say whether they can see the transaction reports where it shows, okay, so-and-so turned this valve to analog to manual or shut the machine down. That's not something a student really needs to see, but it's not important that they don't see it, so it's up to you. Something like electronically sign reports, so if after they've run the process they want to review the machine reports, it's arbitrary whether you allow them to sign it or not. It's just up to you. So for now, I'll say this is going to be your typical student profile. So edit student. Now, if you want to make another student, we can go to Emma, and we can click duplicate. And now we have another user with all the exact same privileges as Emma, and you just get them to fill out their username, password, all that stuff. But we're not going to save them. All right, so now add edit recipes. So I already have a few test recipes made. If you would like, you can just duplicate the recipe to start from. What I would suggest doing though is just creating new recipes from scratch. So you're limited by 3 characters minimum, 16 characters maximum for the name. So you can just say something like, and I'll say Steam. Your naming convention is up to you, however you want. At the top, you have the options to say, okay, product name, container, number of containers. Those don't affect anything in the recipe itself. That's just for your records. So if you know you're going to be cooking peas with this recipe, you can say, okay, this recipe has been tuned to cook 40 cans of peas, something like that. It doesn't affect anything the machine does. That's just for your records. In this case, it's all just tests, so I'm not going to fill any of it out. This is going to be a steam process. Now that I've made a steam process, it temporarily fills out with some just starter information. But first, it asks for initial temperature right here, and it says min 32, max 300, max 200, excuse me. What that's asking is, when you start a process on the machine, the first thing it will do is ask you, what's the initial temperature of this product? This is where you decide what you'll accept. If it's important, the product goes into the machine at 140 degrees, plus or minus 5 degrees, then this is where you would set that range. If the product doesn't fit in that range when you put your IT in, when you start the process, the machine won't start. The machine won't start running the recipe.
How does it detect the pan
So
temperature?
it asks you. So you would put a probe in a can and say, okay, this can is, 115 degrees or 70 degrees or what have you. You'd put your IT in. So it can't detect, so you can lie to the machine. It's not going to stop it. You'll just have to live with the fact that you lied to a machine. Directly to the right of that is the storage tank. So for all steam processes, the storage tank has been grayed out because there's no preparation of water that needs to be done for a steam process. It's just blasting your product with steam. If you run a water immersion process or a water spray process, it needs to prepare hot water for that. And this is where you would put those values in. So if you don't put any values there when you try and run a water spray process or a water immersion process, the machine literally won't run. The first thing it does is use the pressure in the storage tank for those processes to pump the hot water to the top tank. And if you haven't filled out a temperature or a pressure for that step, your process will not run.
Now, which part of the screen are you on right now?
So the storage tank, that little box right there. So you can see it's grayed out because we're running a steam process. But if I were to change this to a water spray process, you can see I can now put those values in. So typically you want to say, okay, 200 degrees, 30 psi. Because if you don't put those values in, it's not going to make any hot water in the bottom tank. The recipe won't be able to go.
And these are the values that you're telling the machine to put the water at in the storage tank at this temperature under this much pressure and then at this level in the storage tank.
Correct.
Correct.
So levels grayed out because it doesn't have an analog level associated with that. It's just got the on-off, okay, I'm full, I'm not full. So it's just kind of a leftover from a different machine that would have that feature. But you need to specify the temperature.
You want it preheated to 190 degrees.
Correct. That's where you put that information in.
Okay.
I've gotten a lot of calls, hey, my machine's not running, and when I look at their recipe, they didn't put any parameters in there.
The reason for the pressure is if you wanted to preheat above 212, you need the pressure to keep it from boiling off. Is that right?
So the pressure is in the machine we don't have a pump to get the water from the bottom tank to the top tank. The pressure is, it opens up a pipe and it just uses the difference in pressure. So there's no pressure in there, there's pressure in there, so the potential just pushes the water to the top tank. So going to run a steam process, so I'm setting it back to steam. You have the two cooling type options. You have spray cooling and flood cooling. It's up to you which one you want to decide, whichever you think will work best for your product. I would typically recommend spray cooling as it has just a better temperature profile. You have very cold water here, so you tend to cool very quickly. So what spray cooling will do was it will fill the vessel to about 9–10% full of water, that top vessel, and then it will turn the pump on and just circulate that water and sprinkle it onto your product. It will run the heat exchanger. It will pulse the heat exchanging water on and off to cool the water that's circulating through the loop, but your water isn't changing. So that first 10% of water that you fill the vessel with and then begin circulating, that's the same water that's going to stay in the vessel for the rest of the process. A flood cool is almost identical to a spray cool, only instead of stopping at 10%, it fills the vessel almost all the way up to 80 or 90% above your product, and then it begins circulating the water.
Does that Versatort have the ability to spray cool also or no?
I'm not
I
familiar with
don't
the
have, it's not
Versatort.
set up to do it right now. I'm just kind of thinking if I could do that.
So it depends what the Versatort is. The Versatort normally a steam machine, or is it?
It's steam, water immersion. The only thing I haven't run on is the spray.
So I'm pretty sure if it can run water immersion, it can run spray because they're almost identical processes. Now, it may not have been set up in the code to run spray, but it should be able to. Just, I don't know anything about the machine, but just from what you've told me, it sounds like it would be able to. Now, after you selected your cooling type, for this one I'll just select spray cooling. You can select your agitation type. If you want the machine to rotate during this process, you would select rotation. Otherwise, you just set it as none. And directly above the agitation menu, you can see 90-degree drain. So now what that does is after it's drained, after your process is done in the drain step, it will turn your can sideways. It's just a little quality of life feature, so all of your cans will have a bunch of water on the tops of them. And when it turns at 90 degrees like that, it just allows the water to drip out from between them, so as you pull the cans out, it doesn't get you wet. It's not really something that's important. Typically, I just select it anyway. So your first step in a steam process is come up vent open. So it's going to run steam until the vessel is fully saturated with steam. Typically you want this step to be about 5 minutes. Probably 10 would be more accurate. And during the step, what it's going to do is it's going to open the vent valve and the bleeder valve on the vessel and just pump steam into the process tank until it's hit a point where it's fully saturated. You have access to, what's that?
Where's the back?
So on the machine, you have, let's see, excuse me, here's your vent valve. It's going to open this valve and it's hooked to a pipe that'll run down to the bottom and you'll see it going when the process is running. And you have a bleeder valve, which is this valve.
And the steam's exiting where?
The steam, you see there's a pipe on that side with a small bleeder valve and with small tubing. So this pipe right there.
Oh, it goes out from the bottom.
Right. So you'll see steam forming on the floor right there. And the bleeder valve will stay open the entire process. That big vent valve will only stay open for the first step of the process. The bleeder valve stays open as a visual indicator of steam. So after the come up vent open step is the come up vent close, and that's where it's still building temperature and pressure, but now it's closed the vent. The process tank is fully saturated with steam, so it doesn't need to get out the cold spots anymore. And directly under that is the cook step. So the cook step is essentially not doing anything. All it's doing is it's giving the machine enough steam to maintain temperature, and it's just trying to maintain pressure. It will hold the cook step in the event of a deviation. So if something went wrong and either your come up vent or come up vents open or closed and something with your product deviated, the machine won't progress past the cook step without you directly overriding it.
So on my machine, it's of course much bigger than this, when I run a steam process sometimes, I end up with an excess amount of condensate in the bottom of the vessel.
Right.
And it's got, I think the alarm is set somewhere around 4%, 3.8 or 4%. So what I've done is gone into the analog, I think it's the analog controls, and opened the condensate drain.
Right.
To drop that back down, but that unclear deviation never goes away.
So, right, so once the deviation's happened, it's considered your batch tainted in some way, and that deviation won't go away until you start the next batch. As this machine goes, it will open and close. It will pulse the drain to get rid of that condensate, and there is a little flow control I can point out later. I've got it dialed in pretty well. I've not seen it have any problems with filling up with condensate, but maybe you have a day where the steam is extra wet in the pipes or something like that. The flow control can be adjusted so it takes longer for the drain to close.
I may have to talk to you later about how to do that on mine.
Sure.
Yeah, anyway.
So if you have a pneumatic valve on your drain, it's just a little flow control you can tee into the return air on the dual action pneumatic valve, and it just keeps it closing slower. And you can just adjust it. Anyway, so after the cook step, you have the pressure cool fill step. Now in a spray process, what will happen is it will fill it up with about 10% of water and then move on to the next step, which is a pressure cool step. So as it begins spraying water on the steam will rapidly collapse, and your pressure gets harder to control at that step. So typically what you do is the pump will pulse on and off for about 100 seconds just to try and lessen the effects of those pressure spikes on your system because the steam's rapidly collapsing. It's trying to add air to compensate for that rapid collapse of steam, and it's begun sprinkling the water on. So you'll see a little bit of movement, I guess, in your pressure level right there, but the pump will pulse for a few seconds during that step. If you select the flood cool step, it's already filled up the entire tank with water. There's no need to pulse the pump. It will just run normally. So directly after the pressure cool step, you'll see atmospheric cool step, which is almost identical to a pressure cool step, only it's open the vent valve and it maintains about 2 psi in the vessel. So it's just cooling your cans at around atmospheric pressure. Now you'll see for every single step you have access to changing the time, changing the temperature, changing the pressure, and changing the RPM. So even though we've selected rotation for this process, if I don't set the RPM for every single step in the recipe, it won't run the rotor. So if I start back from the top again, so I'm going to give this a 7-minute come up, vent open, to achieve 200 degrees. And you'll see directly next to the temperature, you have a little checkbox that says ramp. What that does is it will slowly slope your temperature. So if you give the machine 10 minutes in this step, and you say, I want to attain 200 degrees, but I want to ramp my temperature, it will slowly, instead of having the steam valve wide open, it will have it partially open. So it takes the entire 10 minutes to meet that 200 degrees. If you don't select the ramp, it will blow a bunch of steam in there, get it up to 200 degrees, and then close the steam valve, and it just sits there for the 10 minutes. Same thing with RPM. You could theoretically ramp your RPM if it was very important. It's not really that important.
And your come-up temperatures, the come-up vent open, you said, just as an example, you said heat to 200 degrees.
Right.
There's not a magic temperature that you should heat to. You could go to 20, you could go to...
Right, it's entirely dependent on the products you're running, what packaging the product's in. Just as an example, I'm saying 200 degrees. It's fairly arbitrary what I'm doing.
There's no set or general rule for how long you should have the vent open either.
So the entire point of the process is to get all the cold spots out of the vessel when you're saturating it with steam. Now this isn't a huge tank, it's fairly small, so you can definitely go a shorter amount of time.
So the issue, and you guys thankfully won't run into this, because one, you have much more reliable boiler and steam, and two, it's a much smaller vessel. The problem that I have with mine is if I run longer than, if I try to come up and open as long as 7 minutes at 220 degrees, it'll get to 217 and hold it, and then about 5 minutes in, it starts to drop temperature, because the boiler just can't maintain that temperature.
Right.
So I either have to drop the temperature or drop the time. Otherwise, it'll just sit there until I kill the boiler. It'll just stay there with the venom.
Yeah, I'd say it's more important you have steam going into the machine during that step than any temperature.
So you'll run it at a cooler temperature for the same amount of time, and that'd be all right.
Right.
Okay.
So after that step, where was I at? I'm sorry. Oh, so I was at the come up vent close step. So typically, in the come up vent close step, this is just my personal experience. You can, again, do whatever you want. I would overshoot your cook temperature by 1 degree so it falls into it. So, for instance, if you're running a process and you want it cooking at 250 degrees, you should end your process your come up vent at 251, just so you've overshot that by a little bit. Now, in a steam process, you're not controlling the pressure in the vessel. It's controlled according to the steam table. The steam's controlling your pressure. So you won't have to worry about setting that in a steam process. But when you create a recipe in a water spray process, which I can show you in a second, you're going to want to make sure you hit your time, temperature, pressure on every single step.
And water spray and water immersion, same thing, as far as pressure.
Pretty close.
Okay.
And then I think you said you want to overshoot by 1 degree. Well, with that bias, would that be 2 degrees then?
It would be.
Okay.
But on your HMI, it's going to say 251 instead of
Instead of-
252.
yeah.
Right.
So,
But if you set it to 250, it would technically be at 251.
Right.
Okay.
So if you set to 251, it's going to show 252 on the HMI and 253 there.
Yeah.
I think mine right now goes to, I think it's set to go to 252, and then the TID says 254 or some crazy thing like that. And what I've noticed with mine, with longer cook process, that temperature will slowly drop down to 250, and then you get nervous watching it because you think, oh my God, if this goes below 250, I'm in trouble. And then it just kind of levels right out. So
You can set the safety factor bias to whatever you're comfortable with. We just set it to 1 degree. And again, you've got a much more reliable boiler in this building. I've not seen any problems where it even came close to losing temperature. So you also have, when you're making the recipes, you have your max and min values. And you'll show basically the longest possible you want to be able to have for this recipe, just so if you're going through and duplicating recipes that you can have your students create, you could give them parameters or bound them. And last step we can touch is almost last step we can touch is in the RPM menu, you have the buttons for the home sensor, the 180, 90, and 270. If you have the RPM set to 0 and you select one of those check boxes, what the rotor will do is it will stop moving, but it will rotate until it hits one of those spots. So if you wanted to do something crazy, like have like a 2-minute intermittent flip when you're running a cook, so like it will turn upside down, wait 2 minutes, and turn upside down again, you could make a bunch of come up steps where each step was 2 minutes long. The RPM was 0, but every 2 minutes you would switch between like the 180 and the home sensor. Again, it depends on what kind of agitation you want to see in your machine.
Did you ever go back and forth?
You could, what's that?
I could forward and reverse, instead of going around.
So you mean like a rocking motion?
Yeah.
So this machine can't do that. We do
Okay.
have a few that can, but not this one.
But it only turns in one direction?
It only turns in one direction. If you wanted to manually reverse it for whatever reason, you do have the option to reverse it in the HMI, but that's, hold down the button and it will slowly move backwards. And that's for specific cases, I guess more maintenance situations than anything else. So in normal operation, 99% of the time, it'll always rotate clockwise. So in the segment menu at the top, there's a little box up here. And if you wanted to add it shows all the steps you can add to the recipe. If you wanted to add another one, you would simply just click it and drag it, and it jumps into the recipe. So you can't have more than one cook. You can't have more than one of every single step. The alternate cook is kind of an optional step for every recipe, and that's kind of your safety cook. So if, for instance, you had a problem where it eventually did drop to, from 250 to 249 instead of leveling out, you could throw an alternate cook in, and what
you have to have that set before you start the process. Right?
Correct.
Yeah.
So that would have to be part of the recipe. So you'd have to know, okay, instead of cooking at 250. So if it knew that at 249 you need to cook for 11 minutes and it already cooked for 7 minutes at 250, it would just jump directly in and it would keep the 7 minutes. So it would just go the difference.
If it detects the drop.
What's that?
If it detects the
Right, if it
drop.
detects the drop. If there's no drop in your process, it'll skip the alternate cook entirely.
Okay, and you can set how long the alternate cook is.
Right, or if you wanted to something, if you wanted something like save this product at any cost, you could have 10 alternate cooks. Like, okay, if it drops all the way to 230, I need to go 30 minutes, something like that. So now that we have a recipe, we can either duplicate the recipe, we can delete the recipe. So just for show, I'm just going to pull up the steam recipe I made just so you can see. And it's pretty much identical to what I showed up. Typically you want to ramp in the come up vent close step, not so much in the come up vent open step. You especially want to ramp your temperature and pressure in the pressure cool fill steps. You want your temperature profile and your pressure profile to form a pretty uniform descent. Otherwise, if you cool too quickly without releasing your pressure, you might implode the cans. If you drop your pressure and the cans are still hot, they might explode. All right, return. So now that we've got a recipe, we can schedule it. So I can click this button. I've removed all recipes from the machine, the double arrows. If I select one, I select it, click the arrow, it moves it over. I can move all recipes over with the double arrow. So what I'll do is I'll select my rotating steam spray recipe, move it over, and then schedule. It'll ask me, hey, why'd you do that? I'll just say Allpax testing.
So on the HMI, when you guys go to your operator entries to tell it what to do, which recipe to run, if you don't schedule it, you can't see it on HMI. So you have to schedule it on the main computer before you can do that.
And once you finish the recipe, it's good to go. There's a check mark button, which I'll pull up right now. And there's an activate recipe button. If you don't click that check mark, you can't schedule it. And if you don't schedule it, the machine can't run it. So now the recipe has been activated, scheduled. We can view it here. Now real quick, monitor software can do a few additional things. It has the basic bookkeeping with the creating user accounts. You can also view all the records from the recipes we've run. If I go to my batches, so select view batches, obviously we haven't run any processes today, so I show yesterday's processes and I'll just pick one I ran. And this is basic information about the process you ran, all the mile markers. It's similar to what you saw on the process record screen. They have summary versions, detailed versions. The summary versions are, so once you've finished the recipe, you can view this, make sure everything has gone well in your process. This is more useful for production environments than anything else. But you also have access, in addition to that, you have access to the report trend menu. And so it's the same sort of menu as last time. Select yesterday, you can see all the processes I ran yesterday. So by default, it's going to show you the curve of the storage temperature and process temperature. If I want to see my process temperature versus my process pressure, here's a good way to see my values from the that particular process I ran. Now it's not going to be as useful as your Caltech software, but it's definitely something you can use as a reference. If you wanted, instead of just this picture, if you wanted the actual number value, you would go to the data, you would select the tabular button, and then it gives you the data. The data is captured in 10-second intervals. You can make it higher, but not any lower. So every 10 seconds, it'll capture data from the machine. So you can see, okay, every 10 seconds, this is my temperature, this is my pressure. You can do it for every analog input and every discrete input. It's not as useful for anything other than temperature and pressure, but you definitely could. If you want this data, you would go to Data, Export All, and you would select where you wanted it sent, and it will just send it to a little notepad text file that you can copy and paste into Excel or something like that. Typically, you would use this data in conjunction with whatever your Caltech probes received.
Go back to the graph once. Oh, sorry.
So you go to Report, Trend, Current Trends. So yesterday, I'll just pick, the last one I ran.
So this is what I was talking about when I was saying this green is your temperature line. That is right? Yeah, process temperature. see when you get up here is your cook cycle, 250 degrees. You can see that it bumps up above the 250 a little bit and then slowly drops back down to 250. Your chart on your printout will look the same way, and when you watch that thing, you sit there and watch those numbers drop closer and closer to 250. Because I think your heart is skipping here too. It gets really close to 250. So, and then when you look at the chart, you kind of look at it and go, oh my God, I hope that didn't go over the 250 line, and it doesn't. But it'll get your attention.
And I guess you could always set it to 251.
You could, yeah.
Not as.
If you're like me and you don't like to ride that close to the edge, yeah, you probably want to go 251.
If it does drop, it's still above you.
Right.
Yeah, if it does drop, it will deviate. It'll make a loud noise. You'll see it flashing on the screen, and it won't leave the cook step until you physically override the machine out of that step. So last but not least, you can see the reports that are generated. So monitor transactions is for the monitor software. HMI transactions is for the AllView software. So if you want to know, okay, who's been poking around the machine for the past week, or why is the machine a smoldering crater in the floor, we can see who to blame. And so you can see I've been pushing buttons all day, and it shows you what buttons I push when exactly I push them. And you have something similar for the monitor. So if you say, okay, who went through and deleted all the recipes, there you go.